This video is brought to you by electricalexamcoach.com, offering the #1 electrical exam prep series. You can take our paid version with the Unlimited Testing Center, but you can also take our free version that is completely free without the Unlimited Testing Center. Also, if these videos have been helping you at any time, you can also go there and pay it forward to see it head on to the next generation. I am the Electrical Code Coach. Let's go ahead and get to it. The Electrical Code Coach here, and this is week 6 of the Electrical Code Coach training program. Let's get to it. All right, y'all, we like to always start out with some icebreaker questions. So this week the questions are, if you could have a one-way ticket to be the first on Mars, would you go? And what is your greatest fear about the test? So these are just, things you want to think about, and if you want to drop yours in the comments below, and if you want to hear what the people said when we did the class live, you can head over to the Electrical Code Coach channel and go to my live tab and where we recorded this live. Let's get to it. Round octagonal box would you select for 7 number 14 conductors? All right, so let's see what the question is telling us. It's telling us that it's a round octagonal box, so we know it's going to be one of those 3 choices. And it lets us know that we're starting in the 14 gauge column. So we go to 14. Now we're going to slide down to a box that fits that many. Always start with the smallest and go larger because you want to just fit the number of conductors. So we go 14, 6 won't hold, and 7 will hold. So now we're going to slide over. We're going to tee off and find out what the actual dimensions of the box are. So we've looked at our table, and we find out that our box is going to be a 4 by 1.5. Great job. What size 4 square box would you select for 8 number 8 conductors? So let's all look at the table. As we jump in, this question is letting us know that it's a 4 square box. So we're going to be in the second part of that table from left to right. Those are just the simple square boxes. The ones below that are 4 and 11/16. So it's going to be one of those 3 answers that are in the 4 by section. Okay, so we know that we have number 8 conductors. So we're going to go over to our number 8 column, and we're going to start going down. First, we make sure we get in the right sub-column in the 4 square boxes, and then we're going to start there at the top. The first one is 6. Okay, that's not going to hold. The second one is 7. That's not going to hold. And it looks like it's going to be the third one because anything past 7 is going to be required to be a larger box. So it'd be 8 and up. So in this case, we are going to use the third box, and we slide over and find out that it's a 4 by 2.125 4 square box. And we're going to select A. Let's look at it from a different angle. How many number 10 conductors can you fit inside of a 4 and 11/16 by 1.5 square box? So in this case, it's told us the type of conductor, and it's also told us the box to use. So you're going to start on the left-hand side and find your box first. And when you're doing this, you definitely need to use a sheet of paper or something to come across with so you don't get lost, okay? So first, let's go to the 4 and 11/16 boxes. It's in the third horizontal column coming down, okay? And we find our box is a 4 and 11/16 by 1.5. So that's the second box listed there in the 4 and 11/16 boxes. Now we're going to lay a piece of paper or a ruler or a pencil, something across this as a straight edge so we don't get lost in the sauce. Now we need to come over to number 10 conductors. So we're going to come over and we're going to tee off when we get to the 10 conductor size. And in this case, so we've looked at the table, we're going to find that it will fit 11. You see how we did that? We started on the left-hand side and found our box. Then we came over and we teed off with the size conductor, and we found out that that box will hold 11 10-gauge conductors. Great job. How many number 8 conductors can you fit inside of a 4 by 2.125 by 1.5 device box? So the first thing we're going to do is we're going to find our box. It told us 2 of the knowns, the box and the size conductor. So we're going to go down and we're going to find our box. Now we're down into the device boxes, and there are a bunch of them. So we need to get into the 4 section because it goes 3, 3, 3, and then jumps up to 4. So we're looking for device boxes, and we are looking for a 4 by 2 1/8 by 1 1/2. So that's the first one there when we get to the device boxes that are in the 4-inch section. Now we need to come over and we need to find a number 8 conductor. So we're using a piece of paper or some type of straight edge. We come over and we find that it is 3 number 8s. So we've looked at our table and we find out that it's 3 number 8s. We found our box, we slid over to our respective conductor, and right there we teed off and we found out that it is 3. Great job. Let's look at it from another angle. What is the maximum cubic inch volume of a 3 3/4 by 2 by 2 1/2 masonry box? So this is asking us what is the total volume available. And we learned about this here a minute ago. Now we're going to tie it in because this is super important when we get ready to start doing the other box fill type calculations. So let's go ahead and look at the table. First thing that we're going to do is we're going to find our box. So it told us the type of box and it told us the dimensions. So when we go down here in our types of boxes, we find that there's only 2 masonry boxes that are listed. So let's start at the first one. 3 3/4 by 2 by 2 1/2. That's us. So we're going to lay our piece of paper or our straight edge down, and where we're going to find the cubic inch total is in that middle skinny column. You see the minimum volume column? Remember how we learned about the inches cubed? So what we're going to do is we're going to go and we're going to slide over, making sure that we select from the inches cubed section and not the centimeters cubed, and we're going to find out that it is 14. So the maximum volume of this box is going to be C. It's 14 cubic inches. That's the max volume. And this is really going to come into play next week when we start working through individual conductor sizing. What is the maximum cubic inch volume of a 4 11/16 by 1 1/2 square box? It's the same style question. First thing we're going to do is we're going to look at our table. It's given us the type box and it's also given us the dimensions. So we're going to go down and find the 11/16 box. And we're going to find the 11/16 by 1 1/2. And we're going to come over to the minimum volume section, which is going to let us know our maximum cubic inch volume. And when we look at it, we come over, we use our straight edge, and we're going to find that it's 29.5. That is the maximum cubic inch fill that you're allowed to fill that box. Great job. Let's look at it from another angle. How many more number 10 conductors can you fit inside of a 4 11/16 by 1 1/2 square box that already has 6 number 10 conductors in it? So what we've done is we're switching this around and looking at it from all the different angles. So we go to our table. First thing that we're going to do is we're going to find our box. So we go down, we go into the 4 11/16 boxes, and we find the 4 11/16 by 1 1/2. And we use our straight edge. Now we're going to come over and tee off, and we're going to find our conductor. In this case, it's a 10 gauge conductor. So if the maximum that we're allowed to put is 11, and we already have 6, then all we have to do is do simple math. We take 11 minus 6, and what does that leave us? That leaves us 5. So you can fit 5 more number 10 conductors into this 4 11/16 by 1 1/2 square box. Great job. How many more number 12 conductors can you fit inside of a 4 by 2 1/8 by 2 1/8 device box that already contains 5 number 12 conductors in it? So let's look at our table. We already know the box and the conductor size. So let's go ahead and find our box first. So we got a 4 by 2 1/8. So we're in device boxes. So first find device boxes. Then we're going to find the 4 by 2 1/8 by 2 1/8. So we have to be in the 4 section. Then we come down to 2 1/8 by 2 1/8. And we're going to use our straight edge to get over to our number 12 conductors. So we found our box. We found our size conductor. First find the maximum. The maximum is 6. So what we have to do is do simple math. If we already have 5 number 12 conductors and it only holds 6, how many more can we hold? Looks like we can only hold 1 more. Great job. What is the cubic inch volume for a number 6 conductor? Now this is when we shift gears and we're going to learn the other side of sizing conductors and box fill. And then in the third part of this series, we're going to mesh them all together. So let's go ahead and look at our tables. Remember, we were in table 314.16a last week, and this week we're in 314.16b. If you've already tabbed your code book using our program, then you can use your, your box fill tab. Or excuse me, your box sizing tab. So with that being said, let's go ahead and jump right into it. So let's all go ahead and look at table 314.16b and break it down piece by piece. So we get to our table. Remember, the first thing that you do anytime you come to a table is you're going to read the black bold heading of that table just to make sure you're in the right table, because sometimes you can be on the right page but in the wrong table and you'll end up with the wrong result. And if you're in the middle of testing, you've got to be focused. So the first thing you do, even if it's a familiar table, is you read the black bold heading. So volume allowance required per conductor. That lets us know that we're in the right place. So if we look at this table, on the left-hand side is going to be the respective size wire. So it starts at 18 and goes all the way to 6 gauge. Then if you look at the next column over, that's your centimeters cubed, and we don't ever deal with it in the United States as far as testing goes. So where you're going to switch over is if you go over one more column in the inches cubed column. So as you look down through there, you're going to see the numbers respectively. And what it is the engineers have calculated based off their size and dimensions that this is how many cubic inches that the wire takes up for wire sizing. So let's go ahead and answer our question here. The question was, what is the cubic inch volume of a number 6 conductor? So we start on the left-hand side. We're going to slide down to number 6. When we come over and tee off with the inches cubed column, we're going to find out that it's 5 cubic inches. So for every 6 gauge wire that's inside the box, you are going to have to count it as 5 cubic inches as far as fill volume goes. Now, we're getting ready to learn why and how to apply fill volume. Let's get to it. Let's do one more before we move on. What is the cubic inch volume for a number 12 conductor? Same process. We're going to go to table 314.16b. We look at the black bold heading and make sure that we're in the correct table. We start on the left-hand side and we're going to find our respective gauge wire. Now this is when it's really important that you use a ruler or a piece of paper as a straight edge to make sure that you don't get crossed. So we find a 12 gauge conductor, we use our sheet of paper as a straight edge, and we're going to find that a 12 gauge conductor counts as 2.25 cubic inches as far as box fill volume. Great job. What is the total cubic inch volume for 4 number 12 conductors and 3 14 gauge conductors? So we're going to take everything that we've learned and we're going to put it together here and figure out the total cubic inch volume for a mix of conductors. So we're going to head to table 314.16b, and the first thing that we're going to do is we're going to find what the cubic inch volume is for one number 12. And we're going to find, when we take our time and use our straight edge, we're going to find that the cubic inch volume is 2.25. So what we're going to do is we're going to take our total number of conductors, multiply it by 2.25, and that's going to equal 9. So we have 9 total cubic inches in 12 gauge conductors. Now let's figure out our 14 gauge. So we head back to our table, we come down with our straight edge, and we're going to find that a 14 gauge conductor is 2.0 cubic inch volume per conductor. So we take our 3 conductors, multiply it by 2.0, and that is going to give us 6. Now all we have to do is total those together. 9 plus 6 equals 15, and that's going to equal 15 total cubic inches. Great job. What is the total cubic inch volume for 3 10 gauge conductors and 5 8 gauge conductors? So we're going to head to our table 314.16b. We're going to find our 10 gauge conductor first. So we take it and we tee off and we find that it's 2.50 for each one. So we take our 3 conductors, multiply it by 2.50, and that's going to give us 7.5. So now we go and we find our 8-gauge conductor, and we find out that it's 3.0. So we take our 5 conductors, multiply it by 3.0, and that's going to give us 15 cubic inches. Now we take and we add the two together, and that's going to give us 22.5 cubic inches. And we're going to select B. What is the smallest device box you could use to fit 4 12-gauge conductors and 3 14-gauge conductors? So the first thing that we're going to do is figure out what is our total cubic inches. So we're going to head to table 314.16b. We're going to find the cubic inch volume for the number 12s and then multiply it by the number that we have. We're going to do the same for the number 14s. Then we're going to take and add those together. Now that is our total cubic inch volume. Now that we have the total, we need to head to our first table that we learned about last week, 314.16a. And this is where the magic happens. Now, anytime you're having one of these questions where you're trying to find the total fill, you can typically use the middle column. Remember, I taught you last week called the minimum of volume column. It's the little skinny column right in the middle of that table. Just make sure you're on the right-hand side of that column in the inches cubed and not the centimeters cubed. Now, in order to do this question, we're kind of doing like a reverse lookup question. So what we're going to do is we already have all the information. We just got to find the smallest box. So we need to find the smallest box that will fit it. So the question states what type of box. We're dealing with a device box. So on the left hand, or over in the previous column on the left hand side in the box trade size, we know that we don't need to start looking until we get to where it says device right there. It would be in the 4th column down of the horizontal columns, and it says device, 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 device. So we know it's going to be one of those boxes right there. Now we need to come down into the minimum volume column on the inches cube side, and we're going to get down to where we start to be in the device boxes. Then we just slide down until we find the smallest box that will fit 15 cubic inches. Well, in this case, if you look through all of the device boxes, the only one that will fit 15 cubic inches at all is a 3 by 2 by 3.5 device box, which is going to be allowed to fit 18 total cubic inches. Our question was asking for the smallest box, and in this case, this is the smallest box that can legally fit it. So we're going to select a 3 by 2 by 3.5 device box. Great job. What is the smallest round octagonal box you could use to fit 3 10-gauge conductors and 3 12-gauge conductors? So we're going to head to 310.16b, and then what we're going to do is find out what the cubic inch volume is for a 10-gauge conductor. In this case, we find out that it's 2.50, so we're going to multiply that by our 3 conductors. That's going to give us 7.5. Then what we're going to do is we're going to find out what the cubic inch volume is for a 12-gauge conductor. And in this case, it's 2.25. So we take 3 multiplied by 2.25, and that's going to give us 6.75. Now, when we take and add those together, it's going to give us 14.25. So that's step 1 done. We needed to find our total cubic inch volume. Now what we're going to do is we're going to find the smallest box. So we're going to head to table 314.16a. And what we're going to do is we're going to look in that little skinny column right in the center where it's the minimum volume column. So we need to make sure that we're in our right box selection, which the round octagonal boxes are the first 3. So I come over here to the inches cubed column, I slide down and find one that's big enough to fit 14.25 in it. And it looks like the second one. So when I go back over and I find my box trade size, I find that it is 4 by 1 1/2. Great job. All right, first thing, let's go over some rules for box fill just kind of as a recap. We're going to be working in tables 314.16a and 314.16b. Now that's going to be true all the way from 2008 all the way up to the 2020 code book. There are a few small changes in the 2020 as far as equipment grounds when it comes to box fill, and we will cover it later on in this series. You may or may not be tested on that, but everything else besides the equipment ground conductor count is pretty much the same from 08 all the way into 2020. So let's go ahead and do a little bit of recap. So each conductor counts as 1 for box fill for whatever gauge it is. We're going to recap here. Each conductor that passes through the box counts as 1. So if it comes through, doesn't splice, counts as 1. Internal clamps count as one total for the conductor count based off the largest conductor in that box. So if I have an internal clamp, your question states that it has an internal clamp, or if you're out in the field and there's an internal clamp, it counts as one total, but it's based off the largest conductor that's in that box. So if you have a mix of 14s and 12s, you would count that internal clamp as 112. Each stud or hickey that's present on a light brace shall be counted as one total based off the largest conductor in the box. Each yoke or device strap shall be counted as two based off the largest conductor that's connected to that device. So let's say you had a 2-gang box, you had two 12s terminated to one switch and two 14s terminated to the other. Well, each one of those yokes, which is the metal piece that straps that device, is going to count as two. Okay, and it's going to count for the one on the left, it's going to count as two 12 gauge, and the one on the right, it's going to count as two 14 gauge. And we're going to work through all that over the coming weeks. And equipment ground shall be counted as one total based off the largest conductor in the box in the 2017 and previous. And in the 2020, you can count up to 4 equipment grounds as one. And then there's a 1/4 inch volume increase for each equipment grounding conductor past 4. And we're going to break that down. It's super simple once you get the gist of it, and that's the only change in the 2020 as far as that we're going to be doing for our testing. So with that recap done, if you need to pause it, take a deep breath, go back all over this again, kind of recap, and we're going to go through one question at a time until we master it. Let's get to it. All right, y'all, this week we're going to recap about other items that may be calculated in your box fill. Because we have other items, don't we? We have the devices, we have the, the switches, the receptacles, we have all these fittings, to hang a light. How do we count those as far as box fill goes? We're going to talk about that and recap again today. Remember, this is assuming that you've already taken the free 10-week Journeyman's course on electricalexamcoach.com. Let's go ahead and jump into it. All right, so this is a device yoke. Now, the yoke is the metal part that holds the device in place. It's the strap. It's the yoke. And each yoke counts as 2 of your conductor fill for whatever size wire is terminated to the device. So let's say you have a duplex receptacle. It has 2 spots for the power to come out, and it's on one yoke. And let's say you terminate 12-gauge wire to that device. Well, for your box fill count, it's going to count as 2 number 12s. But if you were to terminate 2 number 14s to that device, it would count as 2 number 14s for your count. And we're going to go over some practice questions here in a minute. One thing that I want to point out about device yokes is that it doesn't matter how many individual little devices are on it. Okay, you could have 3 switches on one yoke and it still counts as one yoke. So just keep that in mind as we go through here. All right, so let's talk about internal clamps. And this is what we're talking about when we talk about internal clamps, okay? These are the clamps that are either factory or field added that actually come inside of the box. So they count as one total. Doesn't matter if you have 4 clamps, they count as one total, and that's based off the largest conductor that's in that box. Let's say if you have 14s, 12s, and 10s inside that box, all the internal clamps would count as one 10-gauge conductor, or whatever the largest conductor is that's inside that box. It only counts as one, doesn't matter how many you have, and we're going to cover this in a question here in a few minutes. And one thing I want to note on this is that it does not count for external clamps. Romex connectors, plastic Romex connectors, any connector that you add on the outside of the box, it does not count anything as far as box fill. Okay, and the last one is a stud or hickey will count as one each based off the largest conductor in the box. So if you had one stud, let me get my pointer here, if you had one stud and one hickey, each one of them would count one time based off the largest conductor in the box. And we're going to break this down and go through it now. Let's get to it. What is the total cubic inch volume you would calculate for a light box that contains 3 12-gauge conductors with one stud and one hickey present in the box? So the first thing that we're going to do is we're going to figure out what the cubic inch volume is for a 12-gauge conductor. As we learned last week, we're going to head to table 314.16b. We're going to come down, we're going to tee off a 12-gauge, and we're going to find that each one is rated at 2.25 cubic inches per conductor. Now we have to get a total count. Well, if we look at our question, we see right off the bat that we have 3 12-gauge conductors. Okay, so we go ahead and write that down. Now we need to figure out how many more to add for any associated equipment or fittings. So in this case, we have 1 stud and 1 hickey, and we just learned that each one of them counts as 1 based off the largest conductor in the box. Well, we have all the same size conductors, so it makes it a little bit easier. So we count each one of those as 1. So we're going to count our 3 base conductors. We're going to add our 2 fittings, which equals 2, and that's going to total together to equal 5. Now we take that and multiply it by the 12-gauge volume. 5 multiplied by 2.25 is going to give us 11.25 cubic inches. Then we're going to select C. Great job. What is the total cubic inch volume you would calculate for a light box that contains 3 12-gauge and 3 14-gauge conductors and 1 hickey present in the box? So first we're going to head to our table 314.16b, and we're going to figure out what is the individual volume for a 12 and a 14-gauge conductor. We find out that each 12 is 2.25. So now we're going to take our 3 base conductors and we're going to add the 1 hickey. And the reason we're adding it to the 12-gauge is because it's the largest conductor in the box. And we're supposed to add it to the largest conductor in the box. So that's going to give us a total of 4 number 12s. We take and bear that math out, and it's going to give us 9. Now we have to calculate our number 14s. So each 14 is good for 2.0. We're going to take 3, which we have, multiply it by 2. That's going to give us 6. Now we have to take and add the total of the 2 together. We take our 9 plus 6, and that's going to give us 15 total cubic inches as far as count. And we select D. Great job. What is the total cubic inch volume you would calculate for a box that contains 8 12-gauge conductors and 2 single pole switches in a 2-gang box? All right, so first we're going to figure out what our cubic inch volume is for each conductor. Each one is 2.25. Now we need to take and total all this up. So right off the jump, we know that we have 8 12-gauge conductors. So we can go ahead and write down 8. Now we need to calculate how many we need to add to it based off the devices. Well, we have 2 single pole switches in a 2-gang box. So that's telling us that we have 2 device yokes. So what we're going to do in this case is we're going to add 2 for each one, which is going to be a total of 4. So we have 4 more conductors. In this case, all of our conductors are of the same size, so we're going to add it to the 12-gauge column. So each one, and we're going to take 8, our original base. We found out that we have 4 more that we have to add because of our devices. That's going to give us a total of 12. Now we take and multiply that by 2.25, and it's going to give us 27. And we select B. Great work. All right, this one's a little bit tougher. If you need to slow down, pause the video, and work through, rewind it a few times, that's okay. Just take your time on it. What is the total cubic inch volume you would calculate for a box that contains 8 12-gauge conductors, terminating to 2 single pole switches, and 6 14-gauge conductors terminating to 2 single pole switches in a 4-gang box? All right, so we're just going to take it one step at a time. First thing you do is you figure out your cubic inch volume for each individual conductor. You have the 12 and the 14. 12 is 2.25. And we know that each device yoke counts as 2 of whatever wire is terminating to the device. So in this case, we have 2 devices for 14 gauge and 2 devices for 12 gauge. All right, so we take our 8 base 12 gauge conductors, and we're going to add 4 conductor count to it because each device counts as 2. So that's going to total 12. Then we're going to take 12, multiply it by the individual volume, and that's going to give us 27 total cubic inch count for 12 gauge conductors. Now let's just turn around and do the same thing for the 14. We find out the individual volume. We find out how many device yokes we have. We take our original count, which is 6 14 gauge conductors. We're going to add 4 to that because we have 2 device yokes. That's going to total 10. Then we take 10, multiply it by the individual volume, and that's going to give us 20 total cubic inches for 14. Now we just take and add the 2 together. We take our original 27, add our 20, and that's going to give us 47 cubic inches. And we're going to select D. What is the total cubic inch volume you would calculate for a box that contains 3 internal clamps and 4 12-gauge conductors? Now we're going to work right back through our rules, and if you ever forget any of these numbers, you can head to 314.16 using your box sizing tab, and you can read through there. And you've got plenty of time in the testing center. It's just a couple black bold headings that you have to read that will give you the count that you need. All right, so let's go ahead and work through this one. We're going to go first to our table, find our individual volume. We're going to find that each one is 2.25, and all internal clamps in the box only count as a total of 1 based off the largest conductor that's inside the box. So we're going to take 4, which is our base number, 12-gauge conductors, and then we're going to add 1 because we have 3 internal clamps, but they only count as 1 altogether. We total those two together, it's going to equal 5, and we're going to take 5 multiplied by 2.25. That's going to give us 11.25, and we are going to select C. What is the total cubic inch volume you would calculate for a light box that contains 3 12-gauge, 3 14-gauge, and 2 field-applied internal box clamps present inside the box? So we're going to look at table 314.16b. We're going to pull our individual volume for our 12-gauge. All internal clamps are going to be 1 based off the largest conductor in the box. In this case, the 12 is the larger gauge conductor. So what we're going to do is we're going to take our 3 base 12-gauge conductors and we're going to add them to the 1 internal clamp. And we're going to do it on the 12-gauge size because it's the larger one in the box. That's going to give us a total of 4. We're going to take 4 multiplied by 2.25. That's going to equal 9. And we're going to do the same thing for 14. We work through the math. It gives us a total of 6. We take our 9 plus 6, and that's going to equal 15. And we select D. Great job. All right, y'all, this week we're going to be learning about equipment ground conductor fill. You guys are in the Master Series. You know that the equipment grounding conductor is the EGC. So I may refer to it as that as we go through. So it's very simple in the 2017 and previous. And then when we get to the 2020, as far as counting the equipment grounding conductor for box fill purposes, it gets a little convoluted. And by the end of this video, I believe you'll be on the same boat as I am, as I don't know why they messed with it, and hopefully by the 2023 code, they will have changed it back. So in the 2017 and previous, all of the equipment grounding conductors in that box only count as 1 as far as your cubic inch volume for the largest conductor that's in the box. And you should have learned about this in the Journeyman series, and we're going to recap in a moment. When you get to the 2020, all of the EGCs count as 1 based off the largest in the box, up to 4 conductors. Then after 4 conductors, there has to be a 1/4 inch cubic inch volume added for each additional EGC after 4 based off the largest conductor that's in the box. So right off the rip, you can tell this is very convoluted. I don't know why they touched this. There's nothing wrong with it, and we're going to learn about it. We're going to recap in the 17, then we're going to jump into 2020. Let's get to it. What is the total cubic inch volume you would have for a box that contained 2 hot conductors, 2 neutral conductors, and 2 equipment grounding conductors, all 12-gauge wire in the 2017 code? So we're going to be referencing table 314.16b. We're going to first count our conductors and see how many there are. So we have 2 hots. We know that they're going to count. We have 2 neutrals. We know that they're going to count. And we have 2 equipment grounding conductors. Well, the code states that we only have to count it as 1. It doesn't matter how many's in the box. It only counts as 1 of the largest conductor that's in that box. So in this case, it's going to count as 1 number 12. So first, let's total our conductors. We have 5. Now, we're going to head back to table 314.16b, and each conductor is 2.25 each 12-gauge conductor. So we take our total conductors, we multiply it by 2.25, and that's going to give us a total of 11.25 total cubic inches for our cubic inch count. And we're going to select C. What is the total cubic inch volume you would have for a box that contained 3 hot conductors, 3 neutral conductors, and 3 equipment grounding conductors, all 12-gauge in the 2017? So we're going to be referencing table 314.16b. And first, let's count up how many that we have. So we know we have 3 hots, 3 neutrals, and all of the equipment grounds we're going to count as 1. And in this case, it's going to be a number 12. So we have a total of 7 conductors. Now we know that each number 12 is 2.25 cubic inch volume allowance. So we take our 7 conductors, we multiply them by 2.25, and that's going to give us 15.75. So in this case, we're done, and we're going to select D. What is the total cubic inch volume you would have for a box that contained 3 number 12 hot conductors, 3 number 12 neutral conductors, 3 number 14 hot conductors, 3 number 14 neutral conductors, and 6 equipment grounding conductors in the 2017? So we're going to be referencing table 314.16b. And let's go ahead and count our 12s up. We have 3 hots, 3 neutrals, and because this is the largest conductor in the box, this is where we're going to account for our equipment grounds. It counts as 1, no matter how many there are, based off the largest conductor in the box. It's going to make our total 7. We know that our cubic inch volume for a number 12 is 2.25. We're going to take 7 multiplied by 2.25, and that's going to give us 15.75. Now let's account for the 14s. We have 3 hots, 3 neutrals, and we have nothing else because we've already accounted for the equipment grounds. That's going to total 6. Now our table lets us know that a 14 is good for 2.0. We're going to take our 6 conductors, multiply it by 2.0. That's going to give us 12. We're going to take our 12 that we have now. We're going to add in our original 15.75. That's going to give us 27.75. And we're going to select D. Great job. All right, guys, let's get into the 2020 stuff. And you'll see by the end of the next couple slides that they've really complicated the process for counting this, and they've really gained nothing. So let's go ahead and jump into it. And hopefully by the 2023 code, they will have fixed this. I haven't got any real-world feedback of the 2020 testers that they're being tested on this for their exam, but I have to assume that you're going to be, because this is a pretty important part of box fill, is, the equipment ground. So let's go ahead and jump into it. What is the total cubic inch volume you would have for a box that contained 7 equipment grounding conductors, all 12 gauge, in the 2020? Okay, so for the first equipment grounding conductor all the way up to 4, it's going to count as 1 based off the largest conductor in the box. Then, so for the first 4, it's going to equal 1x, and in this case, the largest conductor is a 12, so it's going to equal 112. Now we have to have a 1/4 inch increase for each conductor past 4. So let's just take it step by step. So the easiest way to do this is to take your total equipment grounding conductors and minus the 4 and see what's left over. In this case, it's going to be 3. So we have to increase 3 by 1/4 inch each. So we take 3, and I'm going to convert it to decimals so it's easier, and we're going to multiply it by 0.25. Now that's going to give us a 0.75 increase. So it's not even a whole conductor. I'm not understanding, why they did this. So we have a 0.75 increase, not even a whole conductor. Now we have to add that together. We take our original 1 that was counted for the first 4. We add the 0.75. That gives us 1.75 conductors. Now we have to take and bear that math out. Each 12 is rated at 2.25. We take the 1.75, multiply it by 2.25, and that's going to give us 3.9375. The code doesn't address any type of rounding up, so I don't know if we're supposed to round up or what, okay? So we're just going to take that at face value, and we're going to select A. So this is where it gets convoluted. Are we rounding up? What is 0.75 of a conductor? You see what I'm saying? And so if we were in the 2017, we would have counted them all as 1. In the 2020, we've added 0.75 of a conductor. Is that going to be enough to kick us over in box fill? Since it doesn't address rounding up or down, if I have 0.75 over, okay, it really just kind of, just really convolutes things. So let's go ahead. I'm going to show you a little more complex version. And I don't know what they're testing you out in the real world, or if anybody's even caught it, because they might have just, blew through the question, counted all the equipment grounds as 1, and not realized that there's been a change. So let's go ahead and work through one more. All right, so let's do a little more complicated one. What is the total cubic inch volume you would have for a box that contained 6 hot conductors, 6 neutral conductors, and 6 equipment grounding conductors, all 12 gauge, in the 2020? So the first part's real easy. We take our 6 hots, our 6 neutrals. We're going to take each one and multiply it by 2.25. That's going to give us 27 cubic inches, okay, that we've taken up so far with these conductors. Now we have to calculate it for our equipment ground. So for the first and up to 4, it's going to count as 1 based off the largest conductor in the box. Our largest conductor is a 12, so it's going to count as a 1 number 12. Okay, then we have to do the 1/4 inch increase for each conductor past 4. So the easiest way to do it is take our total equipment grounded conductors. 6 minus 4 is going to equal 2. So we have 2 that we need to increase. We take 2, multiply it by 0.25, and that's going to give us 0.50. Now we have to take that and add that back to our original 1. 1 plus 0.50 equals 1.50. Now we have to take that and figure out what it is in cubes. So we take our 1.5 conductors, multiply it by 2.25. That's going to give us 3 and I round it up to 0.8. Okay, so it's 3.38 instead of having some long number. Now we need to take and add that back to our original cubes. That's going to give us 3.38. You add those two together, and that is going to equal 30.38. And we would select C. So you guys can see how this is super complicated, and hopefully the code makers will get together with public input. Typically, guys, how this happens, so you probably don't have to worry about it, is typically what happens is it comes out the first time in the code. Sometimes it's a disaster. Then they regroup. You know, the code maker panels are awesome. And this is just something, you know, they're trying to deal with a huge problem here. So this is not anybody's fault. They're trying to deal with, well, what if we've got 9 equipment ground conductors, equipment grounding conductors in the box? They need to account for something, and I get it, but this may or may not have been the way to handle it. So I'm not going to say it's not the way to handle it, and then we have to look at this question as an example here. It would have counted as 1 in the 2017 and previous. We've added 0.5. Is it going to make a difference in our box fill, like our actual box fill? Now, if you get into 10 equipment grounding conductors, it might. I don't know. But, I mean, is it going to push you into a larger box? I'm just not sure. So it's something that they're going to work out. I love the code makers, code making panel. I think it's an excellent process. I'm not putting down anybody. Just this one here, as far as testing purposes, I feel like it just got out in the weeds. And hopefully they'll bring it back, and I have confidence that they will. I am the electrical code coach. Let's go ahead and get to it. Okay, so let's move on to conductor clearance questions. What is the lowest point you can attach an overhead service conductors to a structure? Take a look at them. Take a guess before we get started. Let's pick apart the question and use our keyword and index process. We're dealing with overhead service conductors, so we flip to O in the index. Go ahead and do that now. Pause the video if you need to. Now that we're in O in our index, we are going to look at our black headings until we find something about overhead service conductors. It looks like the overall theme of our question. Under that heading, we continue to look for keywords. So we did find overhead service conductors. Now, what would you think would be another keyword? Seems like we're dealing with the lowest and highest point that you can attach to overhead service conductors. Look down through there under the overhead service conductor section and see if you can find anything about that. As we look down, we find point of attachment. So it lists 2 articles here. Keep our finger in the back of the index just in case we have to flip back. I want you to go ahead and flip to 230.26. Pause the video now and unpause it when you get back there. We read that in 230.26, it cannot be lower than 10 feet. What is the minimum clearance height for 120 240 volt service conductors coming from the utility pole to a service attachment point that passes over areas or sidewalks accessible only to pedestrians? Let's pick apart the question and use our keyword and index process. We're dealing with overhead service conductors, so let's flip to O in our index. We find under overhead service conductors, we find clearances. I want you to go through those motions now. Go to O, look for overhead service conductors, and our question is talking about clearances. So 230.24 is the first of 3 articles under this section. So make sure you hold your finger in the back or a piece of paper in the back of the index just in case you need to quickly flip back. Go ahead and flip there now. Now that we feel like we're in the right section, we're going to look at the black bold headings until we find what we're looking for. Go ahead and look now and see if you can find anything about conductor clearances. Pause the video now if you need to. Part A is dealing with rooftops, but Part B is dealing with vertical clearances. That sounds like just what we need. We read in section 1 and we find exactly what we're looking for. So go ahead and look at it now. We find that it's 10 feet. All right, let's do another one. What is the minimum clearance height for 120/208 service conductors coming from the utility pole with a service attachment point that passes over residential driveway that is not subject to truck traffic? Let's use the keyword and index process and pick apart the question. We're dealing with overhead service conductors, so flip to O in your index. I want you to pause the video now and see if you can find the answer to this one before we go on. We find under overhead service conductors, we find clearances. Let's try 230.24 first. Part B is dealing with vertical clearances. We read that in section 2 and we find exactly what we're looking for. 12 feet. What is the minimum height for 120/208 service conductors coming from a utility pole to a service attachment point that passes over the city street? I want you to use the keyword and index process now. I know that you can get this one on your own. Remember, overhead service conductors looks like our main keyword, so flip to O in the index, pause the video now, and I want to see if you can find the answer. We find under overhead conductors, we find clearances. 230.24. Part B is dealing with vertical clearances. We read in section 4 and we find exactly what we're looking for. And we're going to select D, 18 feet. Great job. How many feet clearance over door or window must an overhead service conductor maintain? Overhead service conductor, so we flip to O. And I want you to use your keyword and index process, and I want to see if you can find this one. Pause the video now and see if you can find it. We find under overhead conductors, we find clearances. First try 230.24. We looked at in Part C as dealing with clearances from buildings. It refers us back to 230.9, so we flip back and we find that our answer is in Part A. I do want to note that sometimes the code book will send you to another article or another place inside the index. This can seem like a waste of time. It can seem very daunting when you're testing. I'm telling you, when the code book sends you somewhere, you follow it. It seems like a waste of time, but I'm telling you, often you're going to find the answer that you're looking for right away. So in this case, we found ours, and the answer is 3 feet. Okay, here's a good one. Can you support overhead service conductors on trees or other vegetation? Yes, no, maybe so, woohoo, and work for. This one I'm not even going to have you look up. The answer is always no. If you want to check it out, it's article 225.26.